Welcome to Learning Math with Mr. Tan. So today we'll be looking at quadratic sequences, and in this example over here we notice that the first layer of difference is not a common difference, the differences are not constant, and the second layer of difference is a constant. So this kind of sequence is obviously not an arithmetic progression or sequences with common difference. It is not linear, and we characterize it as a quadratic sequence. So notice that the general form over here, the right hand side of the formula, is actually a quadratic expression. Now, whole goal of this topic is to find out what are the values of A, B, and C, so that we are able to form a formula in terms of n, knowing the values of A, B, and C, so that we can substitute whatever value of n in. For example, if I were to find what is the 117th term, then I would just simply have to substitute in n equals to 117 in order to find the term, because I already know the A, the B, the C, and then substitute in the n. So now we want to develop a systematic way of solving for the values of A, B, and C in a given sequence. And if you notice over here, I've already set this up. So I'm going to first focus on explaining how this system of three equations, where I eventually will fill in the right hand side and they will become an equation. In fact, they will become three equations. I'm going to explain how the left hand side comes about. And you can actually use this for whichever quadratic sequences you come across. Okay, so if you notice over here in this general form, I have an squared plus bn plus c. Now the easiest way to do is to take the first three terms. Notice that I have already put down n equals to 1, n equals to 2, and n equals to 3. So you just use the first three terms because the n is actually small, so it's easier for us to work with them. So if you notice here, I can actually just substitute in the n, and I will have t1 equals to a of 1 square plus b of 1 plus c. Now this, if I actually simplify, I'm going to get a plus b plus c. Okay, and I also know that t1 is actually the first term 1, so therefore this is equal to 1, and hence my a plus b plus c is actually 1. So all I need to do is to set this up whichever sequences that you get. As long as you take the first term, it is always a plus b plus c, because when you take the first term, you are actually substituting n equals to 1, n equals to 1, and you're going to end up with a plus b plus c. So by setting it up this way, I get right hand side 1. Okay, so this is our first equation. Okay, and subsequently I can do the same for the rest. For t2, my n equals to 2, so therefore I'm going to substitute 2 into each of here, and I have a of 2 squared plus b of 2 plus c. Okay, and this is going to simplify to, this is 4, so 4a plus 2b plus c. And again, if I always take the second term, I will always be substituting n equals to 2, and therefore I will always, regardless of the sequence that I'm working on, get a 4a plus 2b plus c. So as long as I stick with that, I'm always going to get this expression here, and the second term I just need to substitute in accordingly depending on this sequence. So of course different sequences will have a different second term, and therefore the right hand side will be different, but for this case it will be 3. So therefore 4a plus 2b plus c is equal to 3, and that's our second equation. Alright, and the third equation, how did I get this, is t3 equals to, again, n equals to 3, I'm going to substitute n equals to 3, n equals to 3, and I will have a of 3 squared plus b of 3 plus c, and this is going to simplify to 3 squared is 9, so 9a plus 3b plus c, and that's how I get that. Again, let me emphasize this. As long as you stay with the third term for any sequence, the left-hand side is always going to end up with 9a plus 3b plus c. So all I need to do, I just need to fill in the right-hand side, which is the third term, and that's 6 for this sequence, and I get this. Okay, so I have now the third equation. So what I'm going to do next is to show you a really systematic way of solving this system of 3 equations, which look a little bit daunting at the start. Alright, it looks scary, but you're going to do it in a very systematic way so that we get subsequently only 2 equations for us to solve, which is a familiar situation of simultaneous equations, 2 equations, 2 unknown. Okay, so my first goal is to eliminate one of the unknown out of these 3, and then ending up with 2 equations, 2 unknown, and then further narrowing down to 1 equation, 1 unknown. Okay, so I'm going to erase this part and we're going to go straight into what we are going to do for this example. So now we're going to start solving this system of equations, and I'm going to do it really systematically. So let me first lay out what we're going to do. We're going to take the second equation minus the first equation, and that's going to give us c minus c, so we are able to eliminate c. And again, we're going to take equation 3 minus equation 2. Again, we will have a situation of c minus c, and therefore there will be no more c. So that's our general strategy for now. So equation 2 minus equation 1 is going to end up with 4a minus a. Alright, of course, eventually if you are more comfortable with this, then you can go a lot faster and just directly write down 3a, okay? And of course, we also have 2b minus b, so plus 2b minus b, plus c minus c. I'm not going to write there, okay? The c is going to be removed, it's going to be eliminated. So right hand side, that will be 3 minus 1. So we will end up with 3a plus b equals to 2. Okay, and that's going to be our fourth equation. Alright, and we're going to do equation 3 minus equation 2. So equation 3 minus equation 2, we're going to end up with 9a minus 4a. So 9a minus 4a plus 3b minus 2b equals to 6 minus 3 on the right hand side, and I also can simplify the left hand side and the right hand side into 5a plus b equals to, this is going to give me 3, and that's equation 5. And as you try more quadratic sequences, you realize that even in equation 4 and 5, the left hand side is always going to end up with 3a plus b and 5a plus b. But I don't want you to end up memorizing too many steps and then getting the numbers all mixed up. So all you need to do is actually to remember this, or if you're familiar with the process, you can always work out the left hand side accordingly by substituting n equals to 1, n equals to 2, and n equals to 3. So moving on from there, we now have a pair of simultaneous equations. We also only have 2 unknowns of a and b, with c completely out of the picture for now. So we're going to proceed to solve this. Again, we're going to be using the elimination method. So now we have b and b. So clearly we're going to eliminate this by taking equation 5 minus equation 4. So equation 5 minus equation 4 is going to give me 5a minus 3a plus b minus b. Of course, plus b minus b, as I mentioned, this is already something that we can eliminate, but it is up to you whether you want to write it. It's fine if I just put it down there. And then I have 3 minus 2, okay, so 3 minus 2 on the right hand side, then I have 2a equals to 1, and on further solving, I get a equals to half, okay, so that's the first value we found, a equals to half over here. Okay, now of course we can substitute this in again, so I'm going to substitute this into one of the equation to solve for b, and a equals to half into, if I'm solving for b, does not matter which one I substitute in, I can substitute into equation 4. Okay, and what I'm going to get is a times half plus b equals to 2. Of course, this is 3 over 2 plus b equals to 2. b equals to, if I subtract 3 over 2 on both sides, I will have 2 minus 3 over 2, and that is again half. Okay, so I have a equals to half, b equals to half, and now we need to find the last one, which is the value of c. So I'm going to substitute. Okay, of course you can name this as equation 6, equation 7, and you write that, but we're getting a lot of equations now. So a equals to half and b equals to half into, now the easiest equation you can substitute into is equation 1. Of course, you're not going to go for 2 and 3. There are numbers that are larger in those two equations. So I'm going to substitute into equation 1. Okay, and what I'm going to get is half plus c equals to 1. Now clearly, this is going to give me 1, and my right hand side there is a 1, so c is just 0. So it can happen that c is equal to 0, and my general term Tn will now become half n squared plus half n. Of course, people who are familiar with triangular numbers would actually know that this is actually n over 2 multiplied by n plus 1. Okay, so it's up to you. You can actually put it in this form, it does not matter. This is probably a more familiar form for many people who has done sequences for some time. Okay, so I'm going to proceed now to show you maybe just another simple example of a quadratic sequence, again focusing on this fact that you can actually just remember this or derive this, and then just putting in the first 3 terms. So remember I said that you just use the first 3 terms, so you have 2, 3 and 6, so I'm going to put here 2, 3 and 6, and that's my first equation, second equation, and third equation. Now you have more terms over here, but we're going to use these terms later on to verify our general term. You don't need them, okay, but it's just to establish this, this is actually a quadratic sequence. Okay, so having more terms, I can see that it is actually not a common difference in the first layer of difference, and in the second layer of difference is actually a constant difference. Alright, so I'm going to be doing the same approach. Remember, it is equation 2 minus equation 1. Okay, and what I'm going to be getting is just 4a minus a, which is 3a. 2b minus b is just going to be b. Alright, right hand side is 3 minus 2, which is 1. So that's our equation 4. So this time around, I'm keeping things really simple so that you can see that, oh, okay, it's really a very efficient way of working things out. Okay, so equation 3 minus equation 2. So notice that I'm actually just subtracting the consecutive equations in that sense. Okay, so 9a minus 4a is going to give me 5a. 3b minus 2b is going to give me b. Okay, and right hand side I have 6 minus 3, which is just 3, and I have equation 5. Okay, so all good. I'm going to further solve these 2 simultaneous equations, so I'm going to take equation 5 minus equation 4, and you can see that we're really just taking equation 2 minus equation 1, equation 3 minus equation 2, and then equation 5 minus equation 4. And what I'm going to get is 5a minus 3a, which is 2a, b minus b, which means b is eliminated, and I have 3 minus 1, which is 2, so a equals to 1 upon solving. So what I'm going to do now is to find out the value of b. So I'm going to substitute a equals to 1 into, again, either one of these equations does not matter, so I'm going to substitute into equation 4. And a equals to 1 means I have 3 times 1 plus b equals to 1. Okay, this is 3. Alright, so b equals to 1 minus 3. So I subtract 3 on both sides. And b equals to negative 2. Okay, so what's left is the value of c. So I'm going to substitute a equals to 1, b equals to negative 2 into, again, the first equation, which is the simplest. All the coefficients, all the numbers in front of the a, b, and c are all just 1. So it's easier for us to work with that. Okay, so I have a, which is 1, plus b, which is negative 2, okay, plus c equals to 2. Of course, I can simplify this into just minus 2. Okay, so I'm going to erase that. Alright, and this is negative 1 plus c equals to 2, and then c equals to 3. So now I have the general term Tn equals to, a is 1, so this is 1, so I have n squared. B is negative 2, so I have minus 2n, and c I have 3, so it's plus 3. So I'm going to check, alright, whether my general term explains my fourth term, at least fourth term. Then you can try for the fifth term. So it's a good habit for you to substitute in one of the n's and check whether your general term is indeed verified. Okay, I can't say it is always going to be true. You need to substitute in many values of n to exhaust all the values of n, but it's a good check, alright, just to verify you should be on the right track. Okay, so I'm going to substitute in n equals to 4. This is the fourth term, and see whether we get 11. So T4 equals to 4 squared minus 2 times of 4 plus 3. Now, this is going to give me 16. Plus 3 is going to give me 19. So if you're more comfortable with that, but I think we should just go left to right. So this is 16 minus 8. So 16 minus 8 already gives us 8. And 8 plus 3 is going to give me 11. So indeed I get 11, and you can try, alright, for n equals to 5 whether you get 18. So this method of very systematically eliminating, first of all, c, and then eliminating b, and then solving for a, and then before you find what are the values of b and c, will be quite easy for us to follow to find the general term for a quadratic sequence. Right? You can try this method for different quadratic sequences. In fact, you can create your own quadratic sequences and verify your answer in this way just for practice. Thank you for watching this video. If you feel that this video has helped you, please give me a like. If you feel that my channel is helping your mathematics, please subscribe to my channel and tell your friends about this channel. Thank you for watching.